Hello and welcome to Maths with Jacob. This lesson will focus on grids. When trying to calculate the area of a shape, the task is made much easier if the shape has a consistent form with straight lines. Finding the areas of squares and rectangles is very easy because the boundaries are straight lines and these two shapes have a uniform nature about them. What do we do when the shapes are irregular and they may or may not have curves defining their boundaries? This is where grids come in handy. One way of overcoming the above problem is by using grids. Using square grids, for example, is a very useful way of finding a good approximation for the area of an irregular shape. The above diagram is a perfect example of how a grid can be used to find the area of the orange shape. Assume the area of each small square is 1 square centimetres. 1 square centimetre. So the small square, I'm meaning this one here, that's part of the grid. Okay, so all the others are the same. So that's 1 square centimetre and all the others are the same. So the area of the orange shape is 4 times 1 square centimetre, so there's 1, 2, 3, 4, plus 4 times half a square centimetre. There's a half, there's another half, another half, and another half. So that gives you 4 plus 2, which is 6 square centimetres. So there's an excellent example of how to use a grid to find the area of the orange shape. Assume that the area of each square on the grid is 1 square centimetre. Same again, that one, the little square there, is 1 square centimetre. Area A, which is this one here. The area is 12 times 1 square centimetre, which is 12 square centimetres. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 square centimetres. Area B. Now let's count the full squares first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times 1 square centimetre plus 2 times half a square centimetre. So there's 1 half there and there's another half. That gives you 12 square centimetres plus 1 square centimetre, which is 13 square centimetres for area B. Area C, let's count the whole squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 times 1 square centimetre. There's a half and another half, so it's 2 times half a square centimetre. So it's 10 square centimetres plus 1 square centimetre, 11 square centimetres. 3 excellent examples of how to use a grid to find area. Assume that the area of each square on the grid is 1 square centimetre, same as before, so that is 1 square centimetre, that area there. The area of the elephant is 13 plus 41 plus 20, which is 74 square centimetres. Now the 13, they're the squares to the left of that dark line. Let's quickly check them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The 41 are these squares here between those two black lines. So that gives you 41 there. And the 20 are the squares to the right of the black line. When we add those 3 up, we get 74 square centimetres. Assume that the area of each square on the grid is 1 square centimetre. Same as before. There's our 1 square centimetre there. The area of the pink star. Okay, let's count the whole ones first. 1, 2, 3, 4. That represents that 4 there. Now we've got 2 plus 2 plus 2 plus 2. Well, where does that come from? Well, if you take that area there and you add that to it, that part there, that gives you 1. That's 1 square centimetre, just by adding those two together. So when you add this one to that one, there's another 1 square centimetre. So 1 square centimetre plus 1 square centimetre, that's where you get 2. And that occurs 4 times. There, 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 and the first one we looked at. So in other words, the area of the pink star is 12 square centimetres. And that's a perfect example to show how we can find the area by using a grid.